Okay, we're going to now go ahead and try to find the domain of functions. Now, a lot of functions, you can put in anything you want, but you often will have a restriction on your domain if you have a variable inside of a square root and or if you have a variable in the bottom of a fraction. Because for functions, we cannot take the square root of a negative. Or if you have the variables in the bottom, you should know that we cannot divide by 0. So if we look at this first one to find a domain, we know we cannot take the square root of a negative. So what's inside of your square root, which is the 8 minus 3x, can't be negative, which means it has to be greater than or equal to 0. Now, if we solve that for x, that's going to be our domain. So we'll go ahead and subtract 8. Now we'll divide both sides by -3. Remember, when you divide by -3, you switch your inequality sign. Now this is your domain. Over here, we actually have both issues occurring. We have variables in a root, and we're dividing by variables. So what's inside of our root can't be negative. And once again, what's in the bottom, we don't want to be 0. So we could set the bottom, which is differences of squares, equal to 0, and we could solve that. So pretty much we cannot use 2 and -2. And what's inside of your root can't be negative. So we're going to take our 4x minus 3, can't be negative, means greater than or equal to 0, and then we solve that by adding 3, dividing by 4, and we get greater than or equal to 3/4. So if we're greater than or equal to 3/4, I'm not going to be real concerned about my -2, because I can only use numbers greater than or equal to 3/4, -2 is not. So I only have to be concerned about being greater than -3/4 and not equal to 2. So that means I'm going to be greater than or equal to 3/4, going up to 2, but not including 2. Then I can pretty much got to skip 2, so I got to go u, start at 2 again, and go up to infinity. So this would be my domain right down here in interval notation. Vertical line test. We can use a vertical line test to decide if this is a function. If I move a vertical line across my function and it crosses my function in more than one spot, it's not a function. In this case, it only crosses it once, so yes, it's a function. When I try the next one, no matter where I put it, crossing it only once, no matter where I move along here. So that one is also a function. When I get over here, I'm only crossing it once here, but once I get to this spot, I'm crossing twice, or over here, I'm crossing 3 times, so this one is not a function. So, zeros of a function are where your graph crosses the x-axis. So down below here, we have actually 3 types of functions. Here we have a function, it's just a horizontal line, it doesn't go up, it doesn't go down, it's always the same, so it's referred to as a constant function. But on the middle one here, we have a function that's going down as you go to the right, or it could be going like this. So we actually have 2 different functions listed here. Either one of these, you go down as you go to the right, so we would say that this is a decreasing function. Looking at the graph on the left, as you go to the right, you're going up. So this is an increasing function, or if we do this one here, this is a second possibility of an increasing function. So as you go to the right, if you go up, that's an increasing function. So we want to graph this, and then we want to go ahead and find our domain. You can see the graph over here, but let's understand why it ends up being that. Now, you're not used to seeing this in this form here. F of x, you know, is y. You're used to seeing it without a root, and so I'm going to square both sides. And you're used to seeing it with x and y on the same side, so I'll add an x squared. You should realize that when it's in this form here, that it's in the equation of a circle. What's after my x and y before I square is my center, so it's centered at the origin. 16 is my r squared, so I get my radius to be 4. So I have a circle centered at the origin with a radius of 4. But because it's only the positive root, and it's y equaling that positive root, it's only the top half of my circle. So I'm going to draw a semicircle with a radius of 4 and only the top half. You can see from here, from my domain, it's how far left and right it goes. Starts at -4 and includes -4 and goes up to +4. Or if you chose the interval notation, we would write this. Your range is how far up and down it goes. It starts at 0, only goes up to 4, so from 0 up to 4, or interval notation, it would be written like this. Then we'll do one more difference quotient problem, and this particular function is your 3 times your input squared minus 2 times your input plus. So difference quotient is always whatever function name you have, x plus h, minus original function over h. So I brought down the minus sign, I brought down the over h. This is my original function here in blue, so I'm going to put down my original function in blue. Now, g of x plus h, my function is 3 times input squared minus 2 times input plus 7. So it's 3 times my input squared minus 2 times input plus 7. My input's what's in the parentheses, so I'm going to put x plus h for each one of those inputs. And it shows up in 2 spots, so I got to put that x plus h in both spots. So now I could go ahead and work this out. I have an x plus h all squared, so that's an x plus h times another x plus h, so I'd have to FOIL that. Then I could go ahead and get rid of the parentheses by distributing through my 3, distributing through my -2. Still over the h. Now I want to still deal with this part right here because I didn't do that before. So I can take that and I can distribute through my negative into my parentheses. Now I get this. Once I'm here, I can start collecting like terms. A 3x squared and a -3x squared, a -2x and a +2x, a +7 and a -7. So now I'm going to write the 3 things I have left on top over my denominator. Notice h is a common factor on top, so I'll simplify that by pulling it out. I have h times the top, h times the bottom, leaving me only with what was in the parentheses on top.